The S4 TWIG is the Solid State Storage System Technical Working Group, and it's an organization within SNIA. It's a committee that's designed to come up with a methodology or a method for testing solid state storage arrays. We're working on a methodology, which is a way to accurately measure solid state array performance. We're making a transition right now from the traditional disk-based arrays to different kinds of solid state storage. We are working to come up with a methodology that lets people test those arrays in a predictable and a fair way. In the past, when we had disk drives, we had to worry about things like what things are called rotational and stroke latency. To get to data, the worst case would be you have a spinning disk and the data that you want is just behind your read head. So the disk has to come all the way back around so that it can read that. When you move to solid state storage, reading is free. There is no difference anywhere in that space where you want to read data. You just go and you access it. You're not waiting for anything else to happen. So it's way faster. There's another major component, though, that's coming into play as well, and that's a way to store less data. Many of the modern solid-state arrays are actually write avoidance applications. So they take data in that's being written to the array. First, they look and see if that exact same data has been seen before. They do a calculation to find that out. If so, they make a reference to that data. They don't store it again, and then they're finished. If they haven't ever seen that data before, they take another look at it and see, can I compress it, make it smaller so it takes up less space? So data reduction is a key difference between a drive-based array and a solid-state-based array. It began with what are called the Tier 0, Tier 1 applications. Now more and more applications are being migrated to solid-state arrays. In the past, it was very common to have one array for one application. And what we're starting to see now is multiple applications running on a single array. NVMe represents a different way of holding on to data. You don't necessarily even need an external storage array anymore. You can do it on what you consider a server. The data is held locally. Because it's non-volatile, the system can take a power interruption, come back up, and all of the data that was there, we hope, is still there when the system reboots and comes back. The new data center could be quite a bit different than what we're used to today, in that supporting many customers, those customers can have their data regionally accessible with applications that will point you to the closest location for whatever you need. Managed as an independent organization like we see with Amazon, we see with Google, we see with Microsoft and others. And traditional local storage in a corporate data center is likely to decline. NVMe, I want to learn a bunch more about that. That's where we're headed next. And for us in the S4 TWIG is going to represent another change. What we're working on now is likely to be an interim step towards that next change that we'll need to address, and fairly quickly.